Okay, so we're back for the next part and hopefully the final part of my distribution box upgrade. I can't see for the wires at the moment. Just for reference, this is the outgoing fan that's connected to my extraction system. Very nifty. Now, for those of you who haven't seen this build yet, this is a distribution box. I have a 130 amp hour deep cycle battery in the house somewhere, and it's charged by solar power. And it's pops out in a little power point in this room. Now, this is a distribution box connected to it. So we know currently this one bypasses the 12.3 volts from the house battery. This is an LM78 or 9 regulated 9 volts. This is a 5 volt regulated output. And this is from a variable supply up on the top of my desk, which you can see as a variant. Right, this little thingy down here is a continuity tester. It's an illuminated beeper. Pretty easy. You put a terminal here and a terminal here, and if a circuit is completed, it beeps. We have some lights here that light up when the fuses blow. Case in point, if I unscrew one of these, so that illustrates when the fuse is blown. So the next part of this project has arrived, and hopefully it's the final one. One of these guys, fresh in from China. We bought a few of them. Now, to show you what this is, I'm going to have to use my trusty Leatherman. Let's see if I can cut my finger off on camera and make for a viral video, because I bleed to death. Well, luckily it didn't turn out that way. Good for me, I suppose. Okay, this is pretty much the same as the 5 volt regulator that's already in there. And I did plan to use a 7805, but I had one of these laying around and I didn't have a 7805. The difference between this guy is it's got a couple of panel mount USB connectors already attached, and that saved me probably a lot of mucking around and frustration. So today, the job is to pull the front off this box and fit this. And hopefully, if everything's done right, that'll be done. That'll be over with. And I'll be able to go back to actually using it. So let's get on with the job. I'm not going to go into too much detail here. It's covered pretty thoroughly in the other videos. So let's just hurry up and get this removed. Now, I should probably point out that the way I'm doing this is not entirely recommended, in that I haven't disconnected the 12 volt supply. Now, that's generally not recommended if you don't want to blow fuses. However, there is an added complication. As I've mentioned in my other videos, I actually run a UPS. But one of the quirks that happens with some of these cheaper UPSs is that they both can provide a potential mains voltage across the battery, but also they connect the DC ground to the mains ground. So if I take my nice grounded soldering iron here and I touch a hot wire on the wrong side of the switch, it shorts the system out. Now, I have fitted an appropriate size fuse to my desk fuse box. Now, I have a little 2-pin low voltage DC wall socket that supplies this, so I can disconnect the whole bench. But my DC lighting, which is running off that same supply, would go out, so it could make this a little difficult. What I am going to do is I'm going to connect the 5 volt USB regulator to the other side of this switch. So hopefully, if I've got it off, I can pull the fuse out and I should be safe. But it's just one thing to keep in mind. You'll see in one of my other videos, I absentmindedly forget, and you see me realize the hard way. But anyway, let's get moving. I'm going to prep everything and get this soldered on. Okay, we're all about ready to go. And normally I would have my handy dandy extraction vent sucking up all the fumes from here, but that's normally powered by these 2 pins, which I can't connect while I'm doing this job. But anyway, let's get started. Now, I'm sorry if it's a bit of an unfortunate angle, but a little bit limited on space here. But here we go. I'm going to thread the ground wire through the back here, beside the switch. Now, I have already tinned these wires. I'm going to run a bit of solder around here, and if you can see past my fat hands. Alright, tinning the iron a little bit as well. Going to tack it onto the ground terminal of that switch, although it doesn't really matter. I could theoretically grab to any one of these, because I've run a common ground all the way through them. The hot wire I have removed this fuse in the fuse holder right here. This hot wire is going to come off, obviously the safe side of the fuse. And I think at this point, I probably want to connect it off that terminal. Now you'll notice I've soldered to these terminals. There's a good reason for that. It's probably because I hate crimp terminals and I'm sick of them. Now, this is probably going to seal its fate as being permanently installed. I'm about to apply solder to the thread. Not strictly recommended, but for my purposes it's going to work alright. So it looks like I've got everything soldered pretty well. The next step will be to test, and I like to test before I put everything back together. It's kind of like when you do a computer and you put the cases back on before you test it. Now I've got nothing and the green light's on that says put a fuse in me. So let's put a fuse in it. And then I'm going to go and have my cup of tea. I've just heard the kettle boil and we'll be back. So what have we got? Oh, not a bad 5 volts. It's fluctuating a little. It might stabilize with a bit of load. But let's go and put the front panels in after I have my cup of tea and we'll see how we go. Okay, so we're about ready to mount these in the faceplate and watch it tip over unceremoniously. Let's grab a big blob of blue tack, which apparently a lot of Americans don't know about, even though it's an American invention. Now, I have discovered when I've gone to fit these that there's a clash, and that would be this panel LED that I had here. Now, that's actually kind of redundant. I don't really need it there, and I'm not too stressed about the hole in the faceplate, so I think I'm just going to rip that out. Especially considering I originally had it designed to have its own switch. Now I'm piggybacking all off the main 12-volt switch. So I'm just going to pull that out. The next difficult decision is deciding on a screw length. And I think these guys might be right. Probably wouldn't have picked them out of the box if I thought anything otherwise, I guess. And they do appear to be about right. So let's see. That is going in. Okay, not really meshing with the thread very well. Let's just try something. Take one of the longer ones. I'll just check this here and see if the thread is right. Oh, the thread is very stiff. That's right. So it's just been a very poorly cut thread. That's right. Well, I'll loosely fit it and we'll get stuck in with some real force after the fact. So I wasn't 100% sure of these hole spacings. Just lost a screw. Here, I've got a screw loose. I wasn't entirely sure of these hole spacings, so I made them slightly oblong. That may mean I need to put a washer in, but let's see. No, that looks like that will be okay. That's in loosely for the moment. We'll get the other one mounted, and to save you a bit of boring footage, we'll jump straight to the finished mounting. Okay, so they're mounted in and screwed in quite firmly. Now, for the OCD afflicted among you, or those of you who suffer something analogous to it, you'll notice that I have one port 180 degrees opposite the other one. There's good reason for that. I plug a whole host of different equipment into this test board, and not all of it is made the same. Namely this guy. If I was to plug it into that port, it won't fit. So I can plug it in that port. It just gives me some options. So let's fire things up. Well, it would appear that I have my 5 volts coming out of it. So let's put all this back together and we'll run some load tests. We'll find out if this thing actually provides the 3 amps that it touts it does. So I'll see you in the next clip. So we're back on the other side of that next clip. And it's time to do some current testing. So ironically, the device I've got that pulls the most current on USB happens to be the one I'm using. So I think that's going to be interesting. We might hear some funny sounds. I'm going to plug this in. There's our funny sound. Now it's reading 0.5 amp. That usually takes a bit of time to ramp up. Let's have a look here and see what's going on. So the actual voltage is dropping a little, which tells me it's probably struggling slightly. Now, I do find after a few minutes this normally ramps up to about 1.5 amp or a little bit more. Considering I'm using USB-C, that I would expect that should pull more, but it could be that it's not detecting that it's a USB 3 port and it's being a little more gentle with it. We'll find out. I'll leave that plugged in for a little bit. In the meantime, I'll demonstrate a couple of other features here. This is the continuity beeper I was referring to, and this is purely for those of you who haven't been following this build. I also got some hypodermic needle size probes, which originally I ridiculed for their 30 volt insulation rating, and then when I had to do the Amiga 2000 repair, they came in really handy. But you can see from here, this will be noisy, but if I hold these on, it actually pulses. That is actually slightly more quiet than it originally was. I put an LM78 or a 9 in line with this just to keep it a little quieter, because it is really annoyingly loud when it is usually in use. So another little thing to kill some time, we'll plug in my exhaust fans, or extraction system if you want to sound fancy. So that is plugged into the top here. We can hear the air flowing through. That's very good for soldering stuff. So at the moment we're still reading 4.88 volts and 200 milliamps. That's interesting. So I might actually just shut everything down. I'll leave it plugged in for a little while and we'll find out what this is. This was just on charge too, so it might actually be only float charging it. I'll see if I can find something that requires a bit more power. So as I suspected, the device was partly responsible. So we're looking at about 0.6 volts. It was pulling about 0.9 amps shortly before I started filming. The voltage is dropping, so that does make me somewhat skeptical about its ability. But I'm going to try something. I'm guessing these things are on a common rail. So I'm going to flip this port over, plug it in the bottom and see if the volts drop plugged into a different output. So obviously it's not going to read any current, but it should register a voltage drop. So 4.97. So maybe my current meter is partly responsible for the voltage drop reading. But by the way, I chose to use a portable power bank here. Being that it's made in China, like a lot of things, it's a little bit less discriminate about regulating how much current it draws. So we'll get out, we'll flip this over, and watch, I'll get it right the first time. Isn't that amazing? Tune into YouTube to see a guy that can plug a USB into a port correct the first time round. And no, I didn't practice off camera. Yeah, so 4.7 volts on that. That is really pulling the voltage down a concerningly large amount, especially for half an amp. So that's very interesting. But that aside, this project is pretty well done. So I'm happy with that. That's about where I'm going to finish this video, and this is the last video in this series for the desktop distribution box build. So I'll have to find something more interesting, and I do have a really interesting one in the works, and it's a project my father built many years ago that's going to be a really good education. And it's retro. You'll like it. Anyway, thanks for watching my channel. It's time for me to turn out the lights and get cracking on uploading. See you in the next one.